Hi, everyone. Lovely to meet you all. I'll go ahead and share my screen quickly. Okay, perfect. Hopefully that's now showing. So firstly, thank you so much to the Bright Test Academy for having us. We're really excited to show you Test Modeler tonight as part of the Tool Discovery Brown Bag. So my name is Lena. I'm a solutions engineer from Curiosity Software, and we'll be going through model-based testing today and how it can be used as a collaborative tool to create automation. So we'll go over some of the challenges of traditional automation and the pros and cons of using low and no code tools. Then we'll talk a bit about how model-based testing can be used to get the best of both of those worlds. And lastly, we'll just go into a brief demo of an end-to-end model and have a bit of Q&A at the end. Okay, good. That slide changed. All right. So we all know that automated tests are not a new concept, and we've heard a lot of the promises of the benefits of automating, such as their efficiency, their increased test coverage, and the cost savings. But for all of these advantages, most tests are still not automated. So in 2022, the World Quality Report by Capgemini reported that only 20% of tests were automated, and 80% of companies report that their testing is still manual. And this 20% figure also includes regression testing, which kind of leads us to this question of why is automation so hard to scale? And if we take a look at what this 20% includes, it does include quite a few things. So the first one being that it does need skilled automation engineers that are often in short supply, and they're also quite difficult to find and costly to hire. So there's a skill issue there. And there's also the cost for the code maintenance, which alone for test automation can contain enough work to become its own separate software development project. And the scripting to create these tests is also labor intensive and repetitive. It can also be hard to match the speed of development, and testers struggle to keep up with the impacts of each new change on their scripts. And these changes can generally contribute to a lack of understanding of the system and what should even be tested in the first place. So all of these reasons make oops, sorry about that. And all of these reasons make automation at scale kind of this daunting undertaking that utilizes a large amount of resources for a seemingly low return. So if you take a look at this figure on the slide, we can see how the investment in automated tests can actually decrease with time due to the changes made in the application. So although your teams might have created a suite of automated tests, that project is never really finished. With each new sprint, the maintenance will be required on those tests to fix those scripts that will no longer work, and while new features will also need new scripts. And good code alone won't be able to fix these issues. So that's where the promise of low and no code kind of comes in. So we have quite a few alternatives to traditional scripted frameworks available now in the market. One particular popular method is record and playback tools, which allow testers to record a test or a journey just like they would with manual testing. And the tool will create automation that will play back their tests. This approach is great in its simplicity and familiarity, but it often creates scripts that are pretty brittle. So if there's a change in that test case, the tester will need to go back and re-record the entire journey. There's also no-code tools, which use a variety of techniques to help testers create scripts without necessarily needing to write or understand code. And the premise of these tools are really great, but because of their nature, they're often limited to the set of predefined actions that they come with little to no customization for custom functions. And both of these record and playback tools, as well as no code tools, tend to be pretty limited in what sort of applications they can test. So oftentimes these tools can do web UI, but they might not be able to do API or mobile and kind of a mix and match of all those. So if we move into the world of low code now, we come across keyword driven frameworks that use an executable collection of keywords to playback tests. And these are a bit more flexible and robust than the previous two types, but they do encounter a few issues when the keywords themselves are unreliable or they're not present for the type of testing a user wants to do. And in these cases, there will still be scripting needed to expand that library of available actions. And one thing that all of these approaches have in common is that they're not really dealing with the issues that prevent automation at scale. Designing and recording tests are still linear, they're pretty time consuming, and they're still non systematic in their approach. And we also haven't touched on the ability to measure test coverage and determine the actual quality of the tests we're making. And if we want to tackle these fundamental issues, we'll need to think a bit more about componentization, reusability, and combinatorics. So we'll take a look and see how model-based testing compares. And model-based testing may already be something you do at your organization. If you've ever created a diagram of your system under test, you're actually already halfway there. So we like to say that it all starts with a good question, where we ask what we want to know more about. The formal definition for model-based testing is a systematic approach to generate test cases from models of system requirements. So practically, you can think of it as a process where you create a model of your system and all of the logic that it contains, and then use that model to generate your test scripts and your automation scripts. Although these things are helpful, we do get a lot more than just those test assets from our model. So in addition to now having a systematic way of creating components automatically, we also have reusable representation of the logic in our system that is adaptable to change. And lastly, we also have a way to quantifiably measure our test coverage and make sure we're doing quality testing. So with all of that in mind, we can go ahead and see what this looks like in practice. So let's go ahead and jump into the demo. All right. So here we have a screen from a HRM system that's going to be adding a employee. And we see it's a pretty standard screen with some fields here, and we'll build a model that represents the logic of the screen and then also execute automation against it. So one of the many accelerators we have is our web UI scanner. And what this will do is pick up the page objects and start to create some identifiers for us. And for today's demo, we do have a web UI demo, but we do have a similar capability to import in existing assets for both mobile as well as API testing. So with our scanner turned on, I'll go ahead and click a few of these elements here. And once we pause our scanner, we could take a look at what it identified for us. So we could see our inputs available here. And the great part about the scanner is it is going to create the XPaths and CSS selectors for us. So we can see here it created a XPath and it also assigned this identifier a confidence level. So what Test Modeler did is it ran this identifier against the web page to see what the probability is that this will be successful to use in our automation. So in this case, it seems like it was pretty confident. It assigned a 100% confidence level. So we can be pretty sure that this will go ahead and work in our automation. So we would go ahead and record our whole journey, and these components now become a part of a reusable automation library inside of our model. So we'll go ahead and click Save here. And then we can go ahead and just upload into our project. So once we have everything scanned, and we go back over to our main modeling canvas, we can now see that all of the assets are available to us as a reusable component. So here is that same page we were looking at earlier with the click of the first name, last name, and middle name fields. And from this stage, we actually have a completed model here for today's demo, and we'll be recreating a part of it as well. But we're now going to think about the logic of the system, and we'll start to design some of the test cases for this page. So if we just want to start thinking about our first journey, and apologies, I still had my scanner turned off, so let me just exit out. We'll start first with a start node. And from here, the first action that our user would take is to go to the URL. So we'll click on that function and import that in, and we'll see it's now placed on our canvas. So the next step after that would be to enter in our first name, which is expecting a string variable. And at this point, it's now going to start to ask us about our test data. So we have a data rule set up in our workspace that essentially says every time I import something that's using a first name parameter, I want to go ahead and generate a certain set of equivalence classes. So we'll go ahead and import that in to see what it looks like. All right. So in this case, we have four equivalence classes here. We have a specific first name as well as an invalid, an empty field, and a valid first name. So we're already starting to generate some negative test cases and improve our coverage by using these data rules. So let's take a look into exactly what the test data is doing in these. So for these fields here, if we take a look now at our data variable assignment tab, we'll see that these just have static test data, which is great in increasing our coverage, but might not be quite as dynamic as we would like it to be. So if we take a look instead of our valid first name, we have a synthetic data generation function inside of here, and this will actually generate new data every single time we generate the test. So if we open up our data painter screen, we come built in with 100 functions that you can use to generate your data, but we can also build custom functions for you and you can import them in as well. So for today's example, we have a generation function for a first name. And if we preview the results, we can see that each time it's generating a new first name for us. Once we have our test data fully inputted, we can just go on to creating the rest of our model, which was essentially the same to the process that I just showed you, where we're importing in different assets and clicking and dragging the action blocks in order to represent the logic of our system. And once the model's built, really all of the hard work is done for you. And we can just start to think about the coverage as well as the test scripts that we want to generate. So if we go over into our coverage tab, we have a couple different coverage profiles available to choose from. So if we open up our coverage profiles, we can see that they have different combinations through the pathways in order to generate the perfect suite of test scripts. So we would define that as the minimum number of test cases for the maximum level of coverage that you're specifying. So for example, if we did a low level of coverage, we're going to cover every action inside of the model. But if we do a high level or an exhaustive level of coverage, this is going to cover every single route, every combination possible inside of our model. So we'll go ahead and choose a exhaustive level. And with that now chosen, we can go ahead and generate our test cases. Okay, great. So for a exhaustive level, so every possible combination through our model representing that add employee site, we have 13 pathways. So this would be covering every single possible combination, so 100% level of coverage. And lastly, now that we have our test cases generated for this component, we can try and do a more end-to-end journey. So I'm going to switch over to a different screen now, and this shows a end-to-end model. So if I just quickly zoom in, so here we have our add employee model from earlier, and we also linked that model up to another model, which represents the login page for that site. So each one of these models are now a reusable component that you can chain together in any order in order to create test scripts. So with that, we'll go ahead and generate our test cases for this model, which is 14 pathways. And then we can finally move on to test execution. So we come built in with some frameworks that you can execute directly inside of Test Modeler, but we can also generate it in any language that you're interested in. Ours is just specifically Java Selenium for today's example. So we'll go ahead and take a look at the results. So here, if we choose the specific test we're interested in viewing, we can see that this test had passed from a prior execution. So we'll just want to take a look at the actual screenshots itself now. Great. So here we can see it's going through our login model. We could tell by these steps as well as the descriptions available as it was executing. So we can see it going through, logging in successfully, and then it's entering in our data for the various fields, creating a user login, and then clicking save. So if we take a look at this screenshot here, we can see that all of the fields were interacted with. They now have data, and it's just about to click save and create our new user. So that would be a full end-to-end of how you would create a model and utilize it to create different test assets. But there's one more thing we want to show you tonight, which is really about that impact of change and how you can measure that using models. So if we go back to our first screen with the add employee, and we'll zoom back into our first name section. Let's say that there was a new business requirement that needed us to test another parameter for this first name. We'll go ahead and click and drag a new task block into our model, and we'll connect it to the rest of our logic we already have modeled out here. So with this new change represented in our system, we'll go ahead and regenerate our test cases once again. And we could see that as we're adding more, so in this case, it did only add one extra pathway, but as we're adding more test cases, all of these changes are going to be represented further down inside of the model's logic, and it'll also be pushed back up to the end-to-end model. So all of your test scripts will automatically be updated. So you no longer have to go in at a code level to change things. You can go ahead and edit the model instead, making it a single source of truth. So I'll just switch back quickly to one slide just to end today's demo, and then we can go into a bit of a Q&A. So just to summarize a couple of the things that we saw today, so models are a touch point between code and no code. So they have the full flexibility of code with the entry point of no code. So all of the actions that we saw imported from the scanner, if you needed to do something custom that wasn't easily readily available, you can input it in any language that you would like. And these models will auto-generate the smallest set of tests needed for optimal coverage for any framework you have with just one click. And lastly, we just want to emphasize that anyone can model and anyone can create automation. So we're really trying to help companies build quality throughout the software development lifecycle through collaboration. Thus, we hope that we have all the appeal of low code, but fixing all of the drawbacks at the same time. So thank you so much for having us as part of the test tool night. I will switch over to a Q&A slide and we'll open it up to any questions.
Great. Thank you so much, Lina. Are there any
Thank
questions from the audience? Is there a way to generate a model, or do we need to create it step by step? Is his question.
Yeah, absolutely. So that's a really great question. We can do either way. So the way that I showed you tonight was a bit of a mixture where we're doing a bit of scanning and then we're importing things in with the help of data rules and other AI that we have inside. However, you can build it all just by hand by clicking and dragging components, or when you scan the model, it can auto create an entire one for you. So that option is available inside of our scanner.
Great. Does that answer your question, Frederick? I suppose so. Yes. Any other questions from the audience? I don't know. Do you also support mobile testing? I thought I heard you say that in the beginning.
We do. Yes, we do.
Great.
And everything that you saw tonight would be applicable to mobile. We would just have a different scanner.
Yeah, probably. Yeah. And for APIs, how does that work then in comparison with mobile and web?
Sure. So everything is essentially the same in terms of modeling, but for APIs, we're thinking more about the data combinations. So rather than modeling out, you could model out the logic of how APIs would chain together and work, but you can also model out different combinations of data and how that can be pushed into an endpoint. So it's kind of the same idea of increasing the overall coverage and will auto-generate those combinations of data to push into that endpoint. In terms of the actual importing, we can import in any Postman collections you have, any Swagger specs to create the library of functions that you can pull from.
Okay, great.
Great questions.
Any other questions? Frederick and Stan. So maybe for Stan, is it possible to generate keyword-driven scenarios from a model, for example, BDD?
Yes, we can. I may drop a quick link during the break that shows a
That's
demo
great.
recording of exactly how to do that.
Perfect. Thank you again, Lena. It was really interesting too. And happy to have you here.
Thank you very much.